In our last episode, we explored the reign of the flintlock, a reliable but slow-firing mechanism that dominated battlefields from the 17th to the early 19th centuries, shaping colonial expansion and professional armies across Europe and beyond. But as the 19th century dawned, an unprecedented era of scientific discovery and industrial innovation was poised to shatter these traditions, fundamentally redefining the very nature of warfare. This period, the Industrial Revolution, would accelerate weapon development at a dizzying pace, transforming cumbersome muzzle loaders into instruments of rapid and devastating power. The quest for greater speed, accuracy, and reliability began in earnest, propelled by a world increasingly interconnected and conflict-ridden. The early 19th century battlefield, still largely defined by the single-shot muzzle-loading musket, cried out for improvements. The slow, cumbersome loading process, requiring the soldier to stand exposed, and the unreliability of the flintlock ignition system in wet conditions, posed significant tactical limitations. Commanders understood that even minor enhancements in a soldier's rate of fire or accuracy could dramatically alter the course of battle, giving a decisive edge. This urgent need for innovation fueled a fervent period of experimentation across Europe and North America, as inventors sought to overcome the inherent flaws of black powder weaponry. One of the first and most critical breakthroughs came with the invention of the percussion cap, a revolutionary primer that replaced the unreliable flint and steel. Developed by Scottish clergyman Alexander John Forsyth in 1807, and later refined by Joshua Shaw in America in 1814, the percussion cap utilized a small copper or brass cup filled with a sensitive explosive compound, typically fulminate of mercury. When struck by a hammer, this cap ignited with a powerful, consistent flash, sending a spark through the breech to the main powder charge. The advantages of the percussion cap were immediate and profound. It offered vastly improved reliability, virtually eliminating misfires, especially in damp or wet conditions that had plagued flintlock mechanisms for centuries. The system was also faster to load, as soldiers no longer needed to manipulate a separate flint or priming pan, and safer, reducing the risk of accidental powder ignition. These benefits quickly caught the attention of military authorities worldwide, signaling the impending obsolescence of the venerable flintlock. By the 1830s and 1840s, military forces across the globe began to adopt percussion cap systems en masse. The British Army, for instance, transitioned with the pattern 1842 percussion musket, while the United States Army adopted similar designs, notably the Model 1842 Springfield. This shift marked a significant standardization in firearm ignition, paving the way for further advancements in bullet and barrel design. The percussion cap solidified its place as the dominant ignition system, a role it would maintain until the widespread adoption of self-contained metallic cartridges decades later. While ignition was being revolutionized, another critical area of improvement was barrel design, rifling. The concept of spiral grooves inside a barrel to impart spin on a projectile, thereby stabilizing its flight and improving accuracy, was known for centuries, notably in German Jaeger rifles of the 17th century. However, early rifled muskets were notoriously difficult and slow to load, as the bullet had to be hammered down the tight grooves, making them impractical for military use where speed of fire was paramount. The conundrum of combining rifling with rapid loading was finally solved by French military minds in the mid-19th century. In 1849, Claude Etienne Mini, building on earlier work by Henri Gustave Delvine, introduced the revolutionary mini-ball. This conical lead projectile was slightly smaller than the bore, making it easy to load, but featured a hollow base. Upon firing, the expanding gases would force the base to expand, gripping the rifling grooves, thus imparting spin and vastly improving accuracy and range. This simple yet ingenious design changed everything. The impact of the mini-ball, combined with percussion ignition and rifling, was immediate and dramatic. Rifles equipped with mini-balls could accurately engage targets at ranges exceeding 300 to 500 yards, a significant improvement over the musket's effective range of less than 100 yards. The Crimean War, 1853 to 1856, served as a brutal proving ground for these new rifled muskets, such as the British Enfield and the French mini-rifle. British and French skirmishers, armed with these accurate weapons, inflicted heavy casualties on Russian forces armed with smoothbore muskets, highlighting the devastating advantage of superior range and precision. Despite the advancements in ignition and projectile design, the fundamental flaw of muzzle loading persisted: the need to load from the front of the barrel. This process was inherently slow, required the soldier to stand upright and exposed, and made reloading difficult or impossible from a prone position. The next logical step in firearms evolution was breech loading, where the projectile and propellant were loaded from the rear of the barrel. This promised faster reloading, greater safety, and the ability to fire from various positions. Early attempts at breech loading date back centuries, but most designs suffered from poor gas sealing at the breech, leading to loss of power and dangerous backblast. The Ferguson rifle, developed by British Major Patrick Ferguson in the 1770s, was an ingenious screwbreech design used during the American Revolutionary War. While capable of firing up to 6 rounds per minute, it was complex, expensive, and never widely adopted, primarily due to manufacturing challenges and its limited use in specific engagements like the Battle of Kings Mountain. It was a glimpse into the future, but ahead of its time. The first truly successful and widely adopted military breechloader was the Dreyse needle gun, invented by Johann Nikolaus von Dreyse in Prussia in 1836. This revolutionary rifle used a long, needle-like firing pin to ignite a primer located at the base of the bullet within a paper cartridge. It was the first bolt-action rifle, allowing soldiers to load and fire from a prone position with unprecedented speed. The Dreyse design was a marvel of mechanical engineering for its time, though its paper cartridge and unique ignition system had their own quirks. The Dreyse needle gun's tactical superiority was decisively proven on the battlefields of the mid-19th century. In the Austro-Prussian War of 1866, Prussian infantry, firing from concealed positions, devastated Austrian forces armed with muzzle-loading Lorenz rifles, who had to stand to reload. The rapid-fire capability of the Dreyse allowed the Prussians to deliver a far greater volume of accurate fire. Its dominance was further cemented in the Franco-Prussian War of 1870 to 1871, where despite the French Chassepot rifles' similar capabilities, the Prussian army's overall strategy and effective use of their breechloaders contributed significantly to their swift victory. While breechloading solved the speed problem, paper cartridges remained susceptible to moisture and could leave residue in the barrel. The ultimate solution came in the form of the metallic cartridge. Early attempts, like Casimir Lefouetche's pin-fire cartridge of 1836, demonstrated the concept of a self-contained unit combining bullet, propellant, and primer. These early designs paved the way for more robust and reliable solutions that would soon dominate military and civilian markets. The development of rimfire cartridges marked another significant step. In 1845, Louis Nicolas Flaubert introduced the .22 BB cap, the first commercially successful rimfire cartridge, primarily for indoor shooting. Later, Benjamin Tyler Henry's .44 Henry flat rimfire cartridge, developed in 1860 for the Henry repeating rifle, became widely used during the American Civil War. Rimfire cartridges were simple to manufacture and proved effective, particularly for pistols and smaller caliber rifles, though their primer compound in the rim limited their maximum pressure and reliability in larger calibers. The true game-changer for high-power military rifles was the centerfire cartridge, which placed the primer in the center of the cartridge's base. Developed by Edward Boxer in Britain, 1866, and Hiram Burden in the United States, 1865, these designs offered superior sealing against gas leaks, preventing hot gases from escaping the breech and allowing for much higher pressures. This meant more powerful propellants and greater projectile velocity, making them ideal for military applications in heavy-duty sporting arms. The combination of breech-loading mechanisms with reliable, self-contained metallic cartridges created a synergy that unlocked unprecedented rates of fire. No longer did a soldier need to manually insert powder, then a patch, then a bullet, then prime the firing mechanism. Instead, a single, pre-assembled unit could be swiftly loaded into the breech, drastically reducing the time between shots. This not only increased a rifle's practical rate of fire but also simplified logistics and training, making soldiers more effective on the battlefield with less effort. With efficient breech loading and dependable metallic cartridges in hand, the stage was set for the birth of repeating rifles. These revolutionary firearms allowed multiple rounds to be loaded into an internal magazine, enabling soldiers to fire several shots without reloading after each one. One of the earliest and most impactful was the Spencer repeating rifle, patented by Christopher Spencer in 1860. This lever-action, 7-shot rifle saw extensive use during the American Civil War, particularly by Union cavalry and skirmishers, giving them a significant firepower advantage over Confederate forces still largely reliant on muzzle loaders. Another iconic repeating rifle to emerge during the American Civil War was the Henry repeating rifle, designed by Benjamin Tyler Henry in 1860. Featuring a 16-round tubular magazine beneath the barrel, the Henry could unleash a torrent of .44 rimfire bullets. While its rimfire cartridge was less powerful than some later designs, its sheer volume of fire earned it the moniker "the damned Yankee rifle that they load on Sunday and shoot all week." It became highly prized on both sides of the conflict and laid the foundation for future legendary designs. The success of the Henry rifle directly led to the establishment of the Winchester Repeating Arms Company, founded by Oliver Winchester. Their subsequent models, such as the legendary Winchester Model 1866, often called the Yellow Boy due to its brass receiver, and the ubiquitous Model 1873, cemented the repeating rifle's place in history. The Model 1873, known as the gun that won the West, became synonymous with the American frontier, used by cowboys, lawmen, and Native Americans alike, its rapid-fire capability transforming both warfare and civilian life in the American West. The lever-action mechanism, which characterized many early repeating rifles like the Spencer and Winchester, allowed for incredibly fast reloading and firing with a fluid, natural motion. By manipulating a lever beneath the receiver, the spent casing was ejected, a new round was chambered from the magazine, and the hammer was cocked, all in one swift action. This mechanical innovation greatly enhanced the combat effectiveness of individual soldiers, transitioning from the slow, deliberate pace of muzzle loading to a dynamic, rapid-fire capability that could overwhelm opponents. While lever actions dominated the American frontier, European militaries largely favored refinements to the bolt-action system for their service rifles, prioritizing robustness, precision, and the ability to handle more powerful cartridges. The Mauser brothers, Paul and Wilhelm, perfected the bolt-action rifle, creating designs that would influence military firearms for over a century. Their Gür 1871, adopted by the newly unified German Empire, was a single-shot metallic cartridge rifle, a significant step forward from the Drays. It was a testament to German engineering and precision. The pinnacle of bolt-action development before the turn of the 20th century was undoubtedly the Mauser Gür 1898. This rifle, featuring a 5-round internal magazine, became the standard service rifle for the German army and was widely copied or licensed by numerous nations. Its robust action, powerful 7.92 by 57 mm Mauser cartridge, and exceptional reliability made it one of the most successful military rifles ever produced. Other nations developed their own iconic bolt actions, such as the Norwegian Krag Jorgensen and the British Lee Enfield, each leaving an indelible mark on military history. As repeating rifles pushed the boundaries of individual firepower, inventors began to contemplate an even more radical concept: true automatic fire. The idea of a weapon capable of firing continuously without manual reloading after each shot was a terrifying prospect. The first step towards this was the Gatling gun, invented by Richard Gatling in 1861 during the American Civil War. Though mechanically operated, typically by a hand crank, it was the first successful rapid-fire weapon, essentially a bundle of barrels rotating around a central axis, each loading and firing in sequence. The Gatling gun saw limited but impactful use in the American Civil War, particularly during the Siege of Petersburg. Its true potential for devastating effect, however, was fully realized in later colonial conflicts, such as the Anglo-Zulu War of 1879 and various expeditions in Africa and Asia. British forces, armed with Gatling guns, used them to devastating effect against indigenous populations, who often lacked comparable weaponry. Its ability to pour hundreds of rounds per minute onto an enemy marked a grim new chapter in firepower, forever altering the dynamics of asymmetric warfare. While the Gatling gun was a marvel, it still required manual operation. The next logical leap was a truly automatic weapon, one that harnessed the energy of its own firing to cycle the action. This groundbreaking innovation came from Hiram Maxim, an American inventor, who in 1884 unveiled the Maxim gun. This was the world's first fully automatic, self-powered machine gun, utilizing the recoil energy from each shot to eject the spent casing, chamber a new round, and recock the firing mechanism. It was a technological leap that would redefine warfare forever. The Maxim gun was not just an innovation, it was a revolution. Its sustained rate of fire, often exceeding 500 rounds per minute, could decimate entire formations of attacking infantry in seconds. Its brutal efficiency was chillingly demonstrated during the Battle of Omdurman in Sudan in 1898, where a small British and Egyptian force, equipped with Maxim guns, mowed down tens of thousands of dervish warriors in a matter of hours, inflicting overwhelming casualties with minimal losses to themselves. This battle became a stark testament to the machine gun's unparalleled killing power. The Maxim gun's success spurred further development in automatic weapons. Other inventors, such as Benjamin Hotchkiss with his revolving cannon and John Browning with his gas-operated machine gun designs, contributed to the burgeoning field of automatic firearms. By the late 19th and early 20th centuries, various machine gun designs, each with their own unique operating principles, were being adopted by militaries worldwide. The era of manual loading was definitively over, replaced by the terrifying promise of continuous, overwhelming firepower. The advent of the machine gun, combined with the widespread adoption of repeating rifles, fundamentally altered military tactics and strategy. The open-field charges and linear formations that characterized earlier warfare became suicidal against entrenched defenders armed with such weapons. The devastating firepower of the machine gun foreshadowed the brutal, static trench warfare that would define the coming World War I, forcing militaries to rethink everything from infantry tactics to battlefield logistics. The age of individual heroism gave way to the grim calculus of overwhelming fire superiority. The Industrial Revolution had, in a mere few decades, transformed the musket of Napoleon's time into weapons of unprecedented speed, accuracy, and destructive potential. From the simple percussion cap to the complex automatic mechanism of the machine gun, each innovation built upon the last, creating a cascade of technological advancements. This era of radical change left behind the black powder single-shot firearms, ushering in the age of rapid-fire, metallic cartridge weapons that would arm the armies of the 20th century. These technological leaps created an arms race on an unprecedented scale, irrevocably changing the balance of power and setting the stage for global conflicts. As nations industrialized, so did their capacity for mass-producing these advanced instruments of war, making large-scale, prolonged conflicts a terrifying new reality. The very fabric of warfare had been rewoven, and the world was about to discover the full, devastating implications of these new weapons on an unimaginable scale. Next, we explore how these tools of destruction truly came into their own during the era of total war.